Why are estrogen receptors key to osteoporosis estrogen therapy? Have you ever wondered how estrogen therapy helps manage osteoporosis? The answer lies in estrogen receptors. These receptors are essential for the effectiveness of estrogen therapy because they mediate the protective effects of estrogen on your bones. When estrogen binds to these receptors, it regulates gene expression that controls bone remodeling. This process is crucial for maintaining the balance between bone formation and resorption. Estrogen receptors are found in various bone cells, including osteoblasts, which are responsible for forming new bone, osteoclasts, which break down bone, and osteocytes, the mature bone cells. By binding to these receptors, estrogen helps preserve bone density and strength. One of the key roles of estrogen is to promote the expression of Osteoprotegerin, a protein that inhibits osteoclast activity. Osteoprotegerin works by blocking the receptor activator of nuclear factor kappa B ligand, commonly known as RANKL. RANKL is a molecule that stimulates bone resorption, so when estrogen increases osteoprotegerin levels, it effectively reduces the formation and activity of osteoclasts, leading to decreased bone breakdown. Moreover, estrogen also helps downregulate pro-inflammatory cytokines like interleukin-1, interleukin-6, and tumor necrosis factor alpha. These cytokines are known to increase bone resorption, so by reducing their levels, estrogen further protects against bone loss. Additionally, estrogen promotes factors like transforming growth factor beta, which encourages osteoclast apoptosis or programmed cell death. This action limits bone loss even more. When estrogen levels decline, particularly after menopause, the activation of estrogen receptors decreases. This leads to an increase in RANKL and inflammatory cytokines, resulting in heightened osteoclast activity and bone resorption. This imbalance is what causes the bone loss associated with osteoporosis. Estrogen therapy aims to restore estrogen levels, reactivating these receptors in bone cells. This reactivation helps reestablish the regulatory mechanisms that suppress excessive bone resorption and support bone formation. In summary, estrogen receptors are crucial for osteoporosis estrogen therapy because they are the molecular targets through which estrogen exerts its protective effects on bone. They regulate the expression of genes that control the activity and survival of bone cells, maintaining skeletal health. Estrogen therapy's ability to bind and activate these receptors helps prevent the increased bone turnover and fragility that come with estrogen deficiency in osteoporosis. Understanding this mechanism also sheds light on the use of selective estrogen receptor modulators, which can mimic estrogen's beneficial effects in bone without affecting other tissues where estrogen might be harmful. So, estrogen receptors play a central role in both the mechanism and therapeutic targeting of estrogen in managing osteoporosis.